Okay, so we're going to do a short little video on how to use the scale factor and the ideas of similarity and proportionality to interpret information that is on maps or blueprints or scale drawings of any kind. And the idea behind a map or any kind of scale drawing is, again, to take the proportions between the real dimensions of an actual thing or an actual place and scale them down, shrink them down to a size that we can actually work with. Obviously, if you were trying to build a house based on some blueprints and your blueprints were exactly the size of the house, or the blueprints for the ground floor, you had to lay them out in enough space to actually match what the actual size of the ground floor would be. That would be a little bit ridiculous and impossible to work with. We don't make paper that big. And so on. You can't, obviously, even more so, you can't represent something as large as the earth or a country or even a county or something or a city on paper, at least not on a single uninterrupted sheet. So what we do is we scale things down. Okay, we miniaturize them in order to be able to look at everything and the big picture of things all at once, without losing the actual reality that's there in terms of the proportionality between things and the dimensions. So let's look at this this little map that I've made here, this little blueprint for just some random ground plan for a house floor. You have like the entrance here. The various rooms are all labeled with different things. And the most important thing on a map, in a sense, is always going to be given in the key or the legend of the map. And in this case, it's given here. And that's the scale factor. Okay, again, the scale factor is this ratio, whatever the ratio is between the size of the smaller, similar object or shape and the larger one. So in the case of polygons, the smaller triangle to the larger or the larger triangle to the smaller. It's that ratio between them in terms of the proportionality of their sides. Okay, and so what the scale factor means in terms of a triangle is, if I have, like, let's say this right triangle and this one, and I don't know, this is 4, this is 1, let's say 2, 8, and this is probably not a correct number. I could have something that's exact here, but it doesn't matter for the purposes of illustration. Let's say this is 14, and this is 14 over 4, or 7 halves. Okay, 7 over 2, 3.5 basically. The scale factor between these is, again, it's the ratio between the sides that correspond. So if these are similar triangles, then we have 4:1 in this direction, or 1:4 in the other direction. Okay, and these other ratios are also 4:1. 8:2 is the same as 4:1. 14 over 4 is also 4:1. So that's the scale factor. What does it actually mean? Okay, in terms of a map like this or a blueprint, well, it means for every single unit that I have on the smaller thing, that is going to correspond to 4 of those units in real life. Okay, so you notice there's no units here. So if I have 1 inch here, the larger shape, or the on a map going from the smaller thing to the actual real life object, its units in the same dimension are going to be 4 times as much. So if it's 1 inch here, it's 4 inches here. If it's here on this map, the scale factor is saying 1 centimeter to 3 feet. So that means that 1 centimeter on the smaller object, which is this blueprint, is going to correspond to 3 real life feet when this house is actually built. Or if we were able to go to this house and measure the side lengths of the walls and everything, every centimeter that we measure on here, we would have to measure 3 feet in real life. Okay, so the scale factor can be represented with units. Sometimes it's represented with units, like you'll see on maps things like 1 inch corresponds to 100 kilometers or something. So for every inch on the map, it represents 100 kilometers in real life of distance. We have an example of that here. You probably can't see it on this map because it's really small down here in the corner, but it gives you the scale factor here. It says, it gives the scale factor as numbers, and then it gives the scale factor as inches to miles. So here it's, in this case, it's 1 inch is 197 miles on this map of Australia. So 1 inch on here corresponds to, if I measure out 1 inch, so let's say, I don't know, it's about the distance between, say, Canberra and, you can't really see it here, but there's a town called Port Macquarie. It's about an inch on the map. Well, in real life, the distance between those towns is 197 miles. Okay, on our map, so it's sometimes given with units, but sometimes you'll see it just as a ratio like this, okay, just one number to another. And so back to the Australia map, the ratio 1 inch to 197 miles is actually the same as 1 to 12,500,000. So you can't see that, but that's what this says down here. So the scale factor is, go ahead and write it up here in the ocean, 1 to 12,500,000. It's written as a ratio like this without units. That means that the units are the same. So if I measured an inch on the map, it's equivalent to walking or traversing a distance of 12,500,000 inches of that same unit. 1 inch on the map is 12,500,000 inches in reality. Okay, or if I measure a foot on the map, it's equivalent to 12,500,000 feet in reality, in the real world. If I measure a mile on the map, okay, which again is ridiculous, we don't usually have maps that are that large, or ever have maps that are that large. But if I did, if this map were a mile long and the scale factor were 1 to 12,500,000, that means that the reality of what I'm representing has a distance of 12,500,000 miles between the 2 points. So how are these the same? Well, if you convert the units so that they match, you will get just a plain ratio like this. Okay, you'll simplify it and you'll get a plain numerical ratio. So let's look at how this works on our blueprint here. 1 centimeter is to 3 feet. Okay, so I have to either convert feet to centimeters or centimeters to feet. I need the same unit, and then I'll be able to cancel my units and come up with a numerical ratio. So 1 centimeter to 3 feet. I'm going to convert 3 feet to centimeters. Okay, in every foot there are 12 inches, and in every inch there are 2.54 centimeters. So 3 feet is the same as 3 times 12 times 2.54 centimeters. So we'll punch that in quickly. Okay, so we've performed the conversion, and 3 feet is equivalent to 91.44 centimeters. So this scale factor, 1 centimeter to 3 feet, is the same thing as saying 1 centimeter forever on the map is representative of 91.44 centimeters in real life. And so that ratio is just a fraction, so the centimeters will cancel. And so this is the same numerically as the ratio 1 to 91.44. Okay, again, we may not want to have decimals here, in which case we would multiply by something to get rid of the hundredths places in the decimal. So if I multiply all this by 100, it's the same as 100 to 9,144. Okay, so that's our simplest whole number ratio for the scale factor. Well, maybe not the simplest, in fact. We could reduce this further. But that's not the point here, really. The point is to show you that you can convert between a scale factor with units to a scale factor that is just a numerical ratio. And it's important to know this because sometimes on maps you'll see it either way. Like in some cases you'll get a little scale factor bar like this where it says 1 inch to every 116 miles or 1 inch to every 197 miles. Or they'll just give you the scale factor as a numerical ratio, like 1 to 12,500,000. And you need to be able to, recognize what that means. So coming back to our little house floor plan here, how do we use this? Well, if I need to know, for example, how much lumber to buy to construct this house, I'm going to need to know the lengths of all the walls. I'm going to need to know things like the the area of each room, okay, the number of square units or square feet or something, for things like flooring or for when I'm painting the walls and so on and so forth. Like I need to know the size of this house in reality so that I can buy the materials necessary to actually construct it, let's say. This is actually this is one of the parts of geometry that's very useful and has real common true life applications. And you don't have to be, a carpenter or a special contractor or an engineer or something to need to use this sometimes. I might just want to remodel something at my house on my own, or I might be working in landscaping, or other jobs will also require sort of this kind of knowledge of how to go from a blueprint or a design to the real dimensions of the actual object. So let's take an example of how we could use this. We could find, the length of this wall along this side of the house. So we would do that by measuring this. Okay, or a lot of blueprints they will draw the measurements on, in fact. So you'll have something like this to indicate this length, and then they'll put the actual length here in terms of feet. But we're going to go ahead and do it sort of the hard way. We're going to measure it. We need centimeters because the scale factor is given in centimeters. So this wall on this side of the house is about 12 centimeters long. Okay, I want to be as accurate as I can, but this is pretty much exactly 12 centimeters. Okay, and now how do I convert that to real life units? Well, I take that scale, that number, and I multiply by my scale factor. Okay, so it's just like a unit conversion, but I use the scale factor to do the conversion. So 12 centimeters on the map corresponds, we know that there's 1 centimeter for every 3 feet in real life. So I multiply this, I'm now in real life dimensions of feet, so 12 times 3 is 36 feet. So this wall here is 36 feet. Okay, in length. I might want to know the length of the entertainment center. So I'll measure that. 2.5 centimeters. And again, same thing. I'll multiply by the form of the scale factor that I need to get the units that I want. So in this case, this is going to be 7.5, so 7.5 feet across this entertainment center here in the family room. Okay, so you can use the scale factor that way. You can go from the map to real life dimensions, but you can also use it in reverse to go from real life dimensions to sizes on the map. So, let's say you have a real house and somebody wants you to draw the blueprints for it. To describe the floor plan accurately, well, you're going to need to know how much your scale factor is, how much you're going to try to scale it down by. So let's use this same one here just for the sake of ease and convenience. And let's say that I go to this real life house and I measure the game room and I find that it's 15 feet wide. Or let's say 15.2. Okay, let's make it a little bit more interesting. Well, how large will I have to draw it on the map? How much space will I have to devote on the paper to signify that width in terms of centimeters? So I can use the scale factor in reverse to go the other way as well. Okay, I know that for every 3 feet in reality, I need to have 1 centimeter's worth of distance drawn on the map. So I use the scale factor, but it's in the reciprocal form. Okay, it's 1 centimeter over 3 feet instead of 3 feet over 1 centimeter. And when I do this multiplication, 15.2 divided by 3, I get 5.8 well, it's about 5.2. It's 5.16 repeating centimeters. Okay, so to scale the house down correctly, I'm going to have to draw that width of the game room to be 5.16 centimeters. Okay, if it were 15.2 feet across the width in real life. Okay, so you can use the scale factor both ways. Once you know the scale factor on a map, it pretty much is the key that unlocks everything, all of the information about the design and about the real life dimensions of the thing. Let's look at another example of a real life situation here with the continent of Antarctica. Okay, this map has a scale factor actually of 1 to 20 million, which is quite high. So that should give you some idea of how big Antarctica actually is. We fit it on this little page here, which is only, a page is 11 inches long this way, and yet the entire continent of Antarctica we fit it on here, so we scaled it down quite a bit. And it's absolutely, it's a massive place, and we don't think about it much. But that's neither here nor there. That's not really what we're interested in. What we want to know is, let's say I want to know what the unit form of this scale factor is. So it's 1 to 20 million. Well, that means 1 inch on here corresponds to 20 million actual inches in distance in Antarctica itself, okay, in the real world. So right now the units are the same, 1 inch to 20 million inches, or 1 foot to 20 million feet. So what I need to do is I need to convert one of these to a different unit. So let's say we're going to keep inches on the map. So this doesn't change. It's 1 inch on here corresponds to, let's say we want to know miles. Okay, we don't want to know 1 to 20 million. We want to know how many miles 1 inch represents. All right, and the way that we will do that, we'll figure this out, is to, again, just do unit conversion. So right now it's 1 inch to 20 million inches. So what I need to do is convert that 20 million inches into miles. Okay, there are 12 inches in a foot, and there are 5,280 feet per mile. Okay, so I've gotten to the units that I want, and once I do this calculation, I end up with the number 31.57 approximately. Okay, so 1 inch on the map represents about 31.57 miles in real life. All right, I had to pause for a minute because I realized this had to be wrong. This is far too low. I missed one of the zeros when I entered this on the calculator, so actually the decimal point is going to move. It's actually 315.66 basically. Is the actual scale here. Okay, so 1 to 20 million is the same scale of 1 inch to 315.66 miles. Okay, so let's use this now that we know some more realistic real-life measurements here. Let's use this scale factor to find the distance on here somewhere. Okay, again, you probably can't see this very well because the map is a little bit small, but if you look, let's find the distance between the South Pole, okay, which is here in the center of the continent, and it's another good landmark. Let's say the George V coast. We're just going to choose an arbitrary point here on the George V coast. Okay, so we're trying to find this distance in reality. So I'll measure it on the map first. And the straight line distance is 9. Now I'm using centimeters and I should be using inches. Okay, because our scale is in inches. So hold on, let's flip it around. 3 3/4. It's about 7/8. 13/16. It's about 3 13/16 inches. Okay, and as a decimal, 13/16 is 0.8125. Okay, so it's 3.8125 inches. Okay, approximately. Our measurement may be off a little bit, so this may be more or less accurate depending on how far off we are. But now we're going to use our scale factor to convert this to real life miles. So 1 inch for every 315.66 miles in reality. And that means that this real distance is approximately 1,203.45 miles, okay, which is quite a good distance. It's about a third of the way across the United States, okay, just to give you an estimate of size, which is a long way. I mean, to drive from here to, say, Idaho is about this distance, and it takes almost 24 hours of driving straight. Okay, so it's a good long way, and that's only half of the distance across Antarctica, really. Well, or maybe a little bit more than half. It depends on where you're measuring from. If you're measuring from this edge of the coast all the way to the tip of the tail, it'd be almost double that. Okay, so it is a relatively large continent. Okay, these are just a couple examples of how to use the scale factor on maps to interpret real life data. And we're going to be giving you an assignment here in the next couple of days that gives you a blueprint and asks you to do this same sort of thing. So if this was confusing to you, please get in touch with me and ask me questions. I will help you, and I truly am happy to help you. People, I think, feel like they've been annoying me. That's not the case. Okay, I'm not that busy that I can't take 5 or 10 minutes to help you to understand something. And in fact, it's going to save me time in the long run to have you understand it and do things correctly rather than to have me sort of struggle to figure out what it is that you don't understand. Like, just be open and upfront. Don't hesitate to give me a call or email me.